So thank you all for joining. I'm going to share my screen just to show you what's going on. So I guess one benefit of Zoom is everyone's name's attached to them. So I'm George Kinnear. I don't really need to say that. But just to explain what's happening in the session today, you've all got access to this course page because you've found us through the Zoom link here. The outline for the session is that I'm going to hand over next to Ian Jones from Loughborough University to give us a bit of a background on the theory behind the errors that students make, the mathematical errors that students make. This is going to be quite hands-on, so we're going to send you into breakout rooms at some point, and I'll come back and explain what's going to go on there. Before we do that, we're going to have a break, so we're going to leave you in the breakout rooms for that break. We'll just send a message to say go away and get a cup of tea, but I think it'll be nice rather than be one big room where it's kind of hard to have a conversation. If you do want to go and get your cup of tea and have a chat, we'll leave you in the breakout rooms for that. Then we're going to come back as a whole group, and after that breakout room activity, hopefully you'll have a lot to say, and we can gather those ideas together as a group. So this is all about the theory and just thinking about some questions and what mistakes students might make. And then towards the end of the workshop, Chris Sanguin is going to show you how you can kind of deal with those in Stack. So again, that's going to be quite hands-on. Chris is going to show you how to add in feedback that addresses common errors to a Stack question. And then we've got a hands-on activity where you can go away and try to do that. So again, we'll send you into breakout rooms where you can work through that together. I think that's all I really need to say at this point. There are resources here that will appear at relevant moments. So you'll have access to the slides. We're recording this, so the recording will be on here later. There's various, as I say, activities that you'll do at relevant points. So I think without further ado, I can hand over now to Ian for his part of the session.
Yeah, thanks, George. Hi, everyone. I'm Ian from Loughborough University, and I am going to attempt to share my screen. Let's go. That looks about right. And I'll just go into full screen. Okay, someone could confirm you're seeing my screen.
Yeah, looks great.
Great, thank you. Yeah, so we're going to have a bit of background theory, and theory is a good thing. I think we should have a theoretically informed approach to our teaching. And the theoretical focus also comes from the origins of this workshop, which was originally, there were two workshops funded by PME, the Psychology of Maths Education International Group, and that was hosted by myself. We had one event in Loughborough in August, and by our colleague Igor from Auckland, and that was held in Massey University in December. And the PME funding, there was various sort of things that PME wanted to achieve, and one was that practitioners, maths lecturers, I guess mostly in this case, they wanted to get them mathematicians and maths lecturers more involved with PME's activities, PME's research activities, the conference. So the idea was to try and get mathematicians involved with some theory to do with maths education, perhaps with an eye to them attending PME. Today's event, which is very much George's event, has some funding from LMS. It's not actually the PME funding doesn't actually stretch to today. But that's just the background of what we're doing. So this is kind of a third run of the workshop for some of us. And can I change my slide? Yes, I can. So we're focusing on errors today. And there's some caveats to the sort of errors we want. We're talking about errors that are in some way systematic. They're not just slips or uninteresting calculation errors, but they seem to be something to do with a student's way of mathematically thinking. We're also interested in errors that are common. And I guess the reason for that is we're thinking about ways we might address errors that are common among students. So we're looking for them that have some sort of mathematical substance and to be common errors. Here's some example from delegates. I must confess I haven't had a chance to include any of the comments from today's delegates, but a little roundup from the last 2 workshops. These are the sort of things that delegates either contributed before the workshop or came out during the workshop. So I guess these are the sorts of things we're talking about. And they can be borderline as to whether they fit in that requirement of them being systematic or common, but that's okay. We're here to have a sort of diverse phase and think about all the possible errors that might have some mathematical meaning to them. Oops. There we go. Okay. And then we're going to approach the theory of student errors in 2 ways. First of all, I'm just going to very briefly go through 3 contemporary accounts. So when we think about these systematic errors, what sort of theoretical accounts can we have for why they're occurring and why they're coming up? So one thing, a lot of our colleagues in Belgium at the moment have been researching this, is natural number bias. So typical things are the ideas like a 10th is bigger than a 3rd. Well, why? Because natural numbers, we see a 10 and 10 is bigger than 3. And there's various other ways that this can occur as exemplified here. So that, I guess, is an overgeneralization from seeing natural numbers in the environment. And there's been a fair bit of research into that, contemporary research. Another is this idea of visual saliency, where the notation of mathematics, which very often is a great help to us, the notation's evolved as it has for good reasons, but there's certain times where the beauty of mathematical notation might lead to these sorts of errors, which I guess we probably all recognise these sorts of things. So that's like a notational error where the pattern matching that we might use in mathematics sometimes isn't as helpful as we might hope. Okay, another few examples. I'm going to rush through this a little bit. And then overgeneralization. This is a sort of fairly classic example from the primary classroom, where the equal sign means do all the operations on the left and write the answers on the right. So we end up with these sorts of situations in the bottom one there, where you can see what they're doing. It's kind of how we maybe all write back of the envelope calculations, but it's not a correct use of the equal sign. And in just in case anyone's thinking, well, I don't teach primary, that overgeneralization has nothing to do with me. There is evidence that even adults, including undergraduates, still display this particular operational view of the equal sign in certain contexts at least. But overgeneralization is probably something we're all familiar with, where students have learned a certain mathematical idea or process, and then they inappropriately but understandably apply it to new situations. So that's some fairly sort of fine-grained contemporary research and theorising of errors. And today what we're going to do is step back a bit and perhaps think of a more umbrella way of theorising and go to an older idea, an older tried and tested idea from maths education. And what do we want our theories to do? Well, in this case, we want it to account for what we see in the world, students' responses. We want to be able to talk to each other and others. We want a theory that provides our language. We want it to explain things, enable prediction. But we also want it to help practitioners, so it's usable across all the things we teach, a wide range of learning ideas, and we'd hope this survives peer review and has some standing in the community. And so the language we're going to use, or the theoretical ideas we're going to use, come from Fishbane. An old theory, but a good one, tried and tested. And Fishbane talked about how mathematical ideas, with their abstraction and their axiomatic constraints, we human beings, they're not very intuitive, perhaps. We're not naturally equipped, perhaps, to deal with these mathematics. It involves a lot of hard thinking and overcoming intuitions. And he suggests that what we do as individuals is we have these tacit models, we have these sort of substitute models based on our real world experiences, and we turn to them to help us to try and understand these more abstract mathematical ideas. I'll perhaps skip over that explanation just to get into a worked example, just to keep us to time. So here's the sort of thing we're going to be looking at today. We're going to be looking at a set of questions. They're from Auckland University. They're provided by our colleague Igor. He's not with us. I assume he's asleep in bed on the other side of the planet at the moment. So a multiple choice question. And we have some options there. We have a correct option, and the other options are perhaps quite tempting to students. And what Igor has been able to provide is some data on student responses to these questions. So from the year 2016, we had 94 students, and that's how the answers broke down. So a lot of them went for plain, but line was also a common option. And we can think about this in terms of a tacit model. It's familiar. We're drawing on what we know, y equals ax plus b, but we're applying it inappropriately. So this is the sort of thinking that we're talking about, getting inside the minds of the students. And I'm sure a lot of you watching this are full of ideas and have seen a lot of this sort of thing in your teaching. Yeah, so I mean, one way we can think about this is trying to get inside the mind of the student, trying to understand how they're thinking, and then using theoretical ideas to try and construct our own ways of anticipating the sorts of errors students make. And of course, the ultimate goal is to help them, well, avoid them in the first place, maybe, make them aware of them, or maybe it's identify them when they occur, more of a cognitive conflict. That's kind of to play for. It's our professional judgment as to how we address these sorts of things. And the main part of the focus today is going to be really anticipating the errors, and it's kind of post-workshop. Hopefully we'll all go away and think about impacting our practice through this. But today we're really going to try and sort of think about how to identify and anticipate these common errors. So we've got this bank of questions. They've been administered at the University of Auckland. So what's nice is we get these response statistics. And they were multiple choice formats. So we've got some empirical data to help support us today. And what we're going to do when we go into our breakout rooms, and George is just going to interrupt in a minute to show you the technology. You're going to have a look at, you're going to be presented with a question that was a multiple choice question. You're going to be asked to design 3 alternative options and to draw on your expectations of students' tacit models, of the sort of errors we might commonly expect. We then have a look at the real options, and we can think about the difference between what our groups have come up with and what was actually presented in the questions. Then we're going to discuss or try and anticipate what the proportions are. What proportion of students get the right answer? What proportion go for our tacit model answers, as we're calling them? And then you get the data, then you get to see the real data. So hopefully it's been quite a fun activity, because there's an element of predicting and then seeing if your predictions come true. Right, that was pretty whistle stop. Hopefully that was clear enough, and George is going to pass back to himself in order to show us where the technology is, how we're going to do this.
Okay, thanks, Ian. I realised after handing over to you that I forgot to explain about asking questions. So let me just show you what to do there. So we have set up a question and answer forum, which you may have seen the link to this. So that's a place where you can post questions, and we'll keep an eye on that, and we will be able to then feed in questions. If you do want to just pop a question in the chat, we will try to notice those as well. But if you really want to make sure you get an answer, pop it in the forum, and we will look at that for the rest of the day as well. So in terms of getting ready for the groups, if you come back to the course page, you'll now be able to see the kind of written version of the instructions that Ian was just showing you. So that's the steps that you're going to go through in your groups. And also on this page, there's a quiz, which Malta has set up for us. So if you take a look at the quiz, there's quite a lot there. Don't be too intimidated by that. We've got 4 different kinds of question, and for each one there's 3 different variants of it. So here's a question about working out the dot product of 2 vectors. If you go to number 3 and number 5, it's essentially the same structure of question, just with different numbers. So those are from different years' exams in Auckland. And if you look at some of the other ones, the style of the question is maybe a bit different. So you've got 3 different definite integral ones. So what I'd suggest is that each group try to do all 4 types of question, and you may want to do more than one within the question if you feel you've not quite got the hang of that type of question. So the way each one works, it's structured to let you follow the steps that Ian set out. So first of all, figuring out what you're going to say is the correct answer and what the possible errors based on tacit models that we might see. Then once you submit that, you'll actually see what the options were given in Auckland, and you can have a discussion about, do they all make sense? Do you know why the teacher went for those options? What tacit model are they based on? And then it's this kind of guessing game. There's a box for you to type in the numbers of the proportion of students that you think gave each answer. Once you submit that question, it will then reveal the next step, which shows you the answer. So it has all the stats. You can be wowed at how often students make mistakes that you thought were going to be very rare. Okay. A question in the chat from Sam. Question 2 is based on actual questions from Auckland. That's correct. Yeah. So this is an actual exam question from Auckland. We've just deleted the options that were given. And at step 2, you're going to see what those actual options were. And at step 3, you see the actual stats about how often. I think it's about 1,000 students they have doing this course in Auckland. So some reasonably big numbers. Okay, so I think Malta is ready to send you off into the breakout groups. Is that correct?
Yeah, maybe a last thing to say is you're going to be in groups of 4 or 5. I think what might be the easiest is if you delegate one of you to kind of do the actual clicking and typing and then just share your screen. And the other thing is that you should have the option in the breakout group to ask for help. So that's a button that lets us know if you're having a technical issue or if you're having a specific question. So if you click on that, if you need help, we'll be sure to pop into your group and give you a hand.
Okay, I'm noticing one other question's popped up in the chat. So are the points relating to the tacit model needed?
Well, if you find the language of tacit models useful, please feel free to use that within your group. If you find it a hindrance, hopefully it just stimulated people into thinking about these things. So how literally you want to take that presentation. As long as we've got lots of good ideas at the end, that's all we matter, all we care about.
Okay.
All right, if we're all ready, I'll send you off into your groups, and we're thinking we'll keep going until about 5 minutes to, and then take a little break.
Well, thanks everyone. And I hope that was in some way satisfying and insightful and interesting. And we've got 15 minutes now just to have a bit of feedback. So I'm chairing this session, but I'm hoping to hear not too much of my own voice. So I'd just like to hear back from people on how they found the activity and any thoughts about students' tacit models, about these questions. Maybe you've started thinking about how you might help such students. Maybe you've been sort of buzzing with thoughts about tacit models, which didn't come up in these multiple choice questions, but you've seen in your own practice. So if we could just contribute to that, and we'll see if people are happy to start contributing. So yeah, if you've got something to offer from your group or your own experience, that'd be great. Over to you.
Vijay or Vijay, do you want to start? Vijay, yeah.
I found it quite an interesting exercise, but part of the difficulty, I guess, is given the levels and how fluent we are in mathematics, was kind of pre-guessing or trying to work out what some of the typical errors were. We were able to come up with some of them, and some of the others we couldn't spot straight away. But it was a really interesting exercise, and I think I was talking to Tim, or we mentioned this in our group, that there's a huge amount of data already out there on, because the OU do a lot of obviously online testing, and so, you know, rather than, it's a really good exercise to use for lecturers, but rather than trying to figure out what might be a common error or mistake, is using the data we already hold, you know. But very, very interesting, very interesting. definitely can inform teaching. I've seen this slightly somewhere else. I think maybe comparative judgment it ties in with, I think. But yeah, that's me.
Thank you.
Yeah, for sure. Thank you. Tim, do you want to take the floor?
Okay, briefly. So I was in the same group as VJ, and despite her commenting about our mathematical skills, there were some questions that we got wrong, and our correct answer was none of the ones in the area. So we were pretty bad at judging the precise numbers of people who answered different questions, but we weren't too bad about getting the ordering right. So we may be vastly out on the numbers, but the ordering was fairly decent, and there were some wrong answers that we didn't have a clue where they came from. And maybe the student who entered them didn't either. But still. But that's me done, I think.
Yeah, I guess there'll always be a student that just guesses one of them. So even if it's a very left field option. All right. Thank you, Tim. Julia, do you want to take the floor?
Yes, so in our group, we had a similar thing, especially for the finding the area. We would like to ask how were these two other distractors arrived at, because we couldn't work it out really. So obviously one of them was the actual integral rather than with modulus, but the others we had no clue.
Yeah, we were talking about this as well here in the main room, that this was the question on finding the area between the curve and the axis, right? We're kind of expecting one of them to be differentiating instead, but
yeah, that didn't come out though as ours. We tried that as well, but it wasn't one of the given answers.
no.
So is there someone here who said them who can tell us where they came from, the other two distractors?
Unfortunately not. Igor's not with us. I mean, the classic thing the area question is designed to capture is integrating without considering the signs, of course. But yeah, I too ended up this afternoon in a discussion about what a certain answer was. Maybe they had run out of tacit models, so just stuck a number in. It did turn out to be the least popular answer with students. So yes, I can't comment on the tacit modeliness of every last incorrect answer.
Actually, for one of them, with the 3 sin x, one of these ones was as popular as the correct answer, and we couldn't work out where it came.
Okay, that's interesting. That's one to go and have a look. I'll go and have a look back at that. Yeah.
All right, Daniel, do you want to take the floor? Daniel.
Yeah, sorry, I just had to unmute in 2 different places like I always do. I think one observation is that we tended to come up with more complicated errors than were given. So we did things like thinking that the cross product might be a sensible error in a dot product question. So possibly we need to scale back where we're putting our distractors, or what level our errors are at in some sense.
Well, I mean, maybe the question writer just missed that. It seems an obvious, it would have occurred to me to have put that as well.
But it may depend on your cohort, and I assume that they know their cohort better than I know their cohort. So,
All right, thank you, Daniel. James, do you want to be next?
Yeah, I was just wondering. So I've seen questions where students are given erroneous proofs and asked to find, where the error in this argument is. But I wonder if actually giving this sort of question to the students and asking them exactly what we've just been asked, why did they make this mistake? What did they forget? What misconception did the others or last year's students have when 20% couldn't do this integral right? I wonder if that sort of could be used as a teaching tool.
Yeah, I believe the group at Nottingham, I mean, this is at secondary level with their work with American schools, have used that kind of idea with students, including sort of contrived exemplar student work that does contain these sorts of mistakes. I dare say people have done it at HE level. I can't think off the top of my head, but yeah. Certainly.
Yeah. That's,
All right.
that's it.
Thanks a bunch, James. Sam, do you want to be next?
Yeah, hey, I think just echoing something that was already said, but just to report kind of the same from our group, we found it quite difficult to correctly guess how many people were getting the right, them wrong. We were getting those percentages quite out in a few cases. So I think it's quite nice that, you know, these kind of e-assessments mean that we actually have access to this data. We can go back and look and, you know, you think you know what some of these errors are, but you're only kind of doing it from trying to remember scripts you've seen in the past if you're not doing this as an e-assessment exercise. It's quite interesting going and seeing some specific data.
Yeah, for sure. And I think Chris is going to talk in the next section a little bit about as well how we can make sure that we can actually see what kind of errors students are actually making. Because I think you're totally right that it can be a bit hard to predict what the most popular mistake is. All right, thank you, Sam. Tim, do you want to be next?
Shall I unmute?
Yeah.
And I assume you mean me, not the other Tim.
Yes.
What I'm about to say is not an original observation because it's something I heard Sally Jordan say. And if you're at the end of the Eames conference, you'll have heard Sally. But this exercise really brought it home for me. With a multiple choice question, you really don't know why a student made a particular mistake because they might have just picked it randomly. And she was looking not just at multiple choice questions, she was doing a similar exercise with open-ended questions, and in several cases was able to come up with a good hypothesis as to what mistake had led to the answers the students had given. And this was particularly true in open-ended questions with randomization, because if you have the same kind of mistaken idea and you see the same, you know, equivalent answer in different random variants, you can be quite sure that that is the mistake the students are making. So it's sort of further argument for open-ended sort of question types like stack rather than multiple choice.
Right, for sure. Thank you, Tim. Andrew, do you want to be next?
Am I unmuted? No
Yes.
video, I'm sorry. Just probably a good audience for this questions. I mean, not particularly related to what we've just done, but something I've been wondering about over the last few weeks is, are there databases of answers? I mean, open databases. I mean, we're all contributing open source and open everything, but it'd be really useful, especially for the person setting the question, is if we had a large number of wrong answers to maths questions. For the exercise we've just done, we had 4 wrong answers, but these 4 wrong answers weren't necessarily what the student would have chosen if they'd done the question without answers. These were 4 wrong answers written by the author of the question, and then the student just had to choose one of these 4 because none of them were none of the above. So that's the question.
Yeah, I think that's a really interesting question, and perhaps relates to part of the first point that BJ made about this data being out there. And part of the reason I got interested in thinking about this for HE level is at secondary level, where I've done a lot of research, you can buy catalogues of errors. There's books, common student misconceptions, and they have been researched and catalogued. And I a few years ago was going around saying, no one's done this for HE. You just can't find such things published. I've since softened a bit on that. It turns out that people do publish about common errors and misconceptions. I just not sure the language is there in the HE literature. So you do get lots of secondary examples. If you put in Google Scholar, common misconceptions, I think at HE, and it's part of how I first started collaborating with Igor, I realised a lot of his research, he doesn't use the language, but is this sort of common student ways of thinking. So I don't think it's sort of, I could well be wrong, but to my knowledge, there's not one place at the moment you can go to find these things published or open access. But I think it is out there in the literature at tertiary level.
Okay, thank you, Ian and Andrew. Sam, you've put your hand up.
Yeah, just to add to that, I don't know whether that's because at the higher education level, it's much more open exactly what material students might have studied. If you're doing this at further education, you can presumably say, right, we're pretty sure they did this module, it contained this content, and therefore these are the errors that that's likely to lead to. Whereas something like some of these sign errors that might occur in these integrals depends whether you've ever done a bit about area under curves as opposed to, okay, that's a bad example, but hopefully the point is clear.
Yeah, no, that's a very good example, and it actually makes sort of researching, how do you feed back to students, how do you overcome these misconceptions, quite difficult, because you've got to identify students with who, as you say, have experienced this and have these display these misconceptions. So no, I think that's a very likely reason.
Okay, thank you. Well, I don't see any more hands, which is quite good timing because it is time to move on to the next session.